in this formulation, you're only supposed to find fixed points. You don't look for things that return back. You pay price in high dimensions, but I claim it's actually cheap. And that was understood by Hill. Now, Hill cheated. He was a gentleman astronomer, so to find motions of the moon, he decided I should do a Fourier series because moon motion seems periodic. And he kept 3 turns in this periodic series. But Poincaré understood that this is a much harder problem because you have to keep infinitely many Fourier modes in this case. And they were the first to find orbit stability. It's more general than mechanics, but that's what it is. So what is this Jacobian matrix? So whenever you have a fixed point condition of some function, then standard way is to follow Newton, which is you look how this reacts to small perturbations, and that gives you a linear approximation to the neighborhood of fixed point and use that to find a fixed point. So you always have to compute variation of this matrix for all lattice size. So this is an n by n matrix. Even though your original problem is one-dimensional, it's just dynamics on a line, the whole thing is infinite dimensional. What does this matrix do? It's a little bit unfamiliar. Many of you know it because it shows up in quantum chaos, but we don't have great intuition about it. There's a beautiful thing that it does, which unfortunately doesn't generalize, which is called fundamental fact. Everybody who does cryptology knows that. The essential thing is that this is the global stability of an orbit of a system, something that satisfies the equations of motion every place, if you perturb it every place along the orbit. So it's a high-dimensional perturbation with lots of eigenvalues and lots of eigenvectors. So now think globally, act locally. This is equation that we already met. There is orbit Jacobian acting on fields following the vectors. But now this orbit Jacobian compares the neighbors, and if I look at the finite block, the neighbors are both to the left and to the right, above and below me, in future and past. And I solve it the same way. I find the points,